air. Sulfur dioxide blocks out the sun, while carbon dioxide traps heat. The increase of both gases triggers decades of intense, seesawing weather patterns.
The climate is disrupted by the initial volcanic eruptions, which cause global cooling because of the dust and the sulfur dioxide, and then probably warming as CO2 begins to build up in the atmosphere. So you have sort of a mix of things, and climates are probably switching back and forth. That makes it pretty hard for animals to figure out how to live.
Even here, in what is now South Africa, 15,000 miles from the Siberian traps, a pall of doom is in the air. The sudden change in the climate creates a whole new challenge for those still living: breathing.
The whole world would have started feeling this because global warming, carbon dioxide doesn't stay in one spot. All this CO2 is going up into the atmosphere in Siberia. The CO2 rapidly disperses all over the globe. So as CO2 increases in percentage over Siberia, so too does it globally.
Not only do temperatures worldwide go up by a few critical degrees, oxygen levels start going down. The Lystrosaurus and Gorgons have no idea what's happening to them. But suddenly, it's getting harder and harder to breathe. Their primitive reptilian respiratory systems simply aren't equipped to handle the thinning air. The hunter and hunted now share the same struggle to survive. Still, it's the little Thrinaxodon that perseveres. Seems like evolution is favoring the ultimate underdog in this crisis. Her small, thin frame makes her better suited to the heat than the bigger players of this lost world, and the bony plate separating her nose from her mouth, a distinctly mammalian trait, enables the Thrinaxodon to breathe and chew at the same time. As the air turns foul, it's a critical adaptation, and it's something the larger, stronger mammal-like reptiles are missing. Another advantage this little species has is its social structure. Like many of today's small mammals, Thrinaxodon lives in a supportive group of family and neighbors.
This animal was denning. It probably had young in that den. It might have even had a communal structure, sort of like a meerkat with multiple individuals living in sort of a community structure. And that's really a hallmark of sort of mammal type of behavior.
Especially in times of stress, communal living can ease the burden of staying fed or fending off predators. But Thrinaxodon is not the only creature to weather the storm so far. A new predator is thriving in the rapidly warming environment. Proterosuchus.
The nasties of the late Permian and the early Triassic are a group called Archosaurs. The meanest, nastiest, and first of them is called Proterosuchus.
Proterosuchus is not a dinosaur, but in time his kind will give rise to them.
It would have looked very much like a crocodile, except a crocodile with legs, not splayed out to the side, but underneath it. His head is up on a neck. It's got a skull that's sort of crocodilian, but a little more compressed to the side.
It was a predator. It may have been aquatic. It may have lived in water and hunted fish and grabbed animals on the bank of the stream. That's a good kind of adaptation, and it was able to be opportunistic.
Being cold-blooded means Proterosuchus uses the sun's energy to regulate his body temperature. The hotter it gets, the better he seems to feel.
We would like to think that warm-bloodedness is a great thing. We're warm-blooded, crocodiles ain't. But when the world was a lot warmer than it is today, you're probably well off being cold-blooded, because one of the big differences is that we need to eat 10 times as much as a crocodile eats. It costs us a lot to be warm-blooded, so Proterosuchus and the archosaurs that evolved from it had a great advantage. They didn't need to find so much food.
It's been 25 years since the first eruptions at the Siberian traps. And still the molten basalt continues to flow. Hardening into pitch-black mountains where nothing can grow. The animals that inhabited the region have been forced out. Like a herd of lost buffalo, the Dicynodons wander endlessly, always on the lookout for an elusive safe haven. The Gorgons of northern Asia have seen their population cut by half due to hunger and disease. The younger generation knows nothing of their ancestors' glory days, just this meager, desperate existence. And there is no relief. More punishment is about to strike from above. Acid rain. The next stage of the disaster is brewing in the atmosphere itself. Volcanic sulfur dioxide combines with water vapor to create sulfuric acid. Now even the rain has the power to kill.
The downwind consequences would have been a lot like living near a really bad Eastern European coal generating plant. I mean, it just would have been an awful place to live.
You see these pictures where acid rain has just killed whole forests, and you have pine trees standing which have turned brown and the leaves are falling. If that's continuing over a long span of time, as probably happened in Siberia, acid rain would kill all of the plant life.
Day in and day out, the caustic liquid rains down on every corner of the globe, killing all the vegetation. And for those with no place to hide, daily life becomes excruciating. Only our ancestor, little Thranaxodon, is small enough to find shelter from the storm. Will Thranaxodon be the only survivor? In what is now the Arizona desert, a tropical floodplain offers little escape from the oppressive conditions. The once majestic forests of conifers, the ancestors of today's evergreens, are dying by the millions. Plant life withers in the stifling heat. With vegetation the foundation of the food chain, starvation now runs rampant. Hardest hit are the large herbivores like Dicynodon. Their bulging abdomens mask an intricate cluster of digestive organs that process the coarse roughage on which they subsist.
These sorts of things. They were largely low nutrition kinds of plants, so the plant eaters would have had to work hard. They would have been eating all day, probably.
Now the Dicynodon's food sources are literally drying up, and new generations aren't adapting fast enough to deal with the growing famine. Their numbers dwindle, but so do the others that feed upon them.
We need to understand there's a food chain operating so that the extinction of plants will affect everything, all the animals, whether they eat plants or not. And the sequence is, if you kill the plants, you lose all or most of the plant eaters. Therefore, you lose all or most of the flesh eaters because they have nothing to eat.
The Gorgons witness their largest food supply simply vanish before their eyes. Where once there was more than enough food to go around, now there's competition for even the smallest prey.
So you've got fewer herbivores. It takes a lot of herbivores, a big territory, to keep a top carnivore alive and happy. As you reduce the food of the herbivores, as there are fewer and fewer of them, they can support fewer and fewer of the Gorgons.
Their primitive reptilian jaw structure was never a problem when food was so abundant. But now, their inability to properly tear a carcass apart is costing them dearly. The Gorgons are starving to death. It's 200 years since the extinction began. Earth keeps inching closer to complete destruction. It's a time of unprecedented annihilation, a depth of devastation never experienced before or since. One predator rises to power, Proterosuchus. The high temperatures are a boon to this cold-blooded creature.
There are times in Earth history when it's better to be a cold blood than a warm blood. If we have a world where it's already warm anyway and it never gets cold at night, I mean, this is a great place to be a cold-blooded animal. You need less energy.
Our ancient ancestor, Thrinaxodon, is also fated for survival. Being a tiny scavenger, she has no problems living on morsels of food that nobody else wants.
Now you have all the insects in the world. You have dead meat that's out here. You have small reptiles. You have amphibians. You have a lot of food sources available to you. When you're a very big top carnivore, that's not the case.
Thrinaxodon embodies tenacity. Where other creatures might give up in the face of such harsh conditions, she fights every day to keep herself and her offspring fed and protected. Perhaps it's her proto-mammalian instincts that drive her. Whatever it is, the future of all mammals, including mankind, depends on her unrelenting will to live. Thrinaxodon wouldn't look much like any mammal alive today. But scientists believe that this small creature was a direct ancestor to modern mammals, including the human race. So how do we know that Thrinaxodon was related to mammals, including mankind? Evidence of its unique mammalian traits comes from the fossil record.
Yeah.
Its spinal column suggests it had a diaphragm, and its snout had holes that suggest it may have had whiskers. If it had whiskers, it probably had hair, and if it had hair, it was most certainly warm-blooded. As more clues are uncovered, science will shed even more light on our ancient ancestors and their evolution. "10,000 years have passed since the Siberian traps first erupted. What started in an isolated region of northern Asia has now engulfed the whole planet. Life on Earth is on the precipice of complete extinction. Everywhere in Pangaea, the vegetation is dead and rotting. And when the summer monsoon